Assalamualaikum warahmatullahi wabarakatuh to doctor and everyone. My name is Nurain Syuhada Binti Muhammad Amiruddin and my metric number is 074579, and today I will be presenting our case study on evaluating data mining techniques for predicting student performance using a dataset from Kaggle. So for the introduction to the case study, the main objective of this case study is to predict student academic performance based on several features like attendance, course, demographics, and more. We are using a real-world dataset of 1,000 students from Kaggle. Our target variable is grade, which range from A to F. The big question we want to answer is how can data mining help educators forecast performance and make better decisions? So for the overview of data mining techniques, in this study, we explore three data mining techniques. First, classification. This technique is used when the goal is to predict a specific category. For us, that category is a student's grade. Second is clustering. Clustering helps group students with a similar characteristic without knowing the actual grade levels. Third, statistical analysis. This method is used to find an info relationship between features like how attendance or sleep hours affect grades. Each of these techniques play an important role in analyzing and understanding the data. Out of three, we choose classification as the best technique for our problem. That's because we have labeled large data, we already know the student grades, and we want to predict this grade for new students. Classification helps schools identify which student might be at risk and allows for early intervention. We selected three top algorithms to test, which is random forest, support vector machine or SVM, and logistic regression. So the first algorithm is random forest. Random forest is an ensemble method that builds multiple decision trees and combines their results. Its strengths include high accuracy, the ability to handle different data types, and it's less likely to overfit. But its limitations are that it's slower to train on a large data set, and it's harder to interpret than a single tree. So for the second algorithm is support vector machine (SVM) works by finding the baseline or hyperplane that separate the classes like grade A from grade B. Its strengths are that it performs well on high-dimensional data and when there's a clear margin between classes. Limitations include the need for parameter tuning, lower performance with noisy data, and it's more difficult to interpret. So for the last algorithm is logistic regression. Logistic regression is one of the most simplest classification algorithm. It uses a mathematical formula to predict the probability of a student falling into a certain grade category. The strength of logistic regression are its simplicity, speed, and easy interpretation. The limitations are that it only works well with linear data and it assumes that the features are not correlated. We tested three different models to see which one worked best. These are random forest, SVM, logistic regression. We use common performance metrics like accuracy and AUC to measure how good each model is. Random forest gave the best result, with very high accuracy and perfect class prediction. SVM and logistic regression didn't perform well. Their score very low and close to random guessing. This table shows the results. As you can see, random forest got 99 accuracy and perfect accuracy. That means it did a great job. SVM and logistic regression had low accuracy and AUC, so that means they didn't work well.
My name is Najibah Rozali. My metric number is 073806. So I'll continue with the next section, which is section B. In this section, I will explain the importance of preprocessing when building a machine learning model, especially in the context of our student grading system dataset. So for the first one is handling missing or inconsistent data. Datasets often contain missing values, such as absent grades or incomplete attendance record. Ignoring these can lead to poor model performance. Handling them properly, either by filling missing values or removing affected rules, helps the model learn more accurately. The second one is encoding categorical variables. So, machine learning algorithms cannot process categorical data like genders or course name directly. These values must be converted into numerical form using encoding techniques to ensure the model can interpret and utilize data correctly. The third one is normalization and standardizations. Features like scores, attendance, and study hours are usually on different scales. Without normalizations, models may place more importance on features with larger ranges. Standardizing the data helps the model treat all features fairly, especially in algorithms that rely on distance or gradients. Lastly is outlier detections. Outliers such as students with perfect scores but no attendance can mislead the model. Identifying and handling these outliers prevents skewed results and improve the model's ability to generalize the new data. After processing, the next step is identifying which features are most relevant. Feature selections helps in reducing noise and improving model performance. So the first one is reducing dimensionality. Removing irrelevant or redundant features simplifies the models and speed up training. Fewer features also reduce the risk of overfitting. The second one is improving interoperability. In education sector, it is important for stakeholders such as teachers or administrators to understand model decisions. Focusing on key features like attendance, assignment scores make the predictions easier to interpret. The last one is eliminating noisy or unrelated features allow the model to concentrate on the most informative data, which improve overall accuracy. Preprocessing and feature selection play a key role in improving the performance of a predictive model, especially in the education domain. These two steps directly influence three important aspects, which is accuracy, reliability, and interpretability. So for the accuracy, preprocessing ensures that the data used in the training is clean, consistent, and free from irrelevant information. Feature selection focuses only on the most relevant attributes, such as assignment scores, quiz average, and attendance. As a result, the model can make more accurate predictions of student grades because it learns from meaningful and precise data. For the second one is reliability. Aware preprocessed data sets and carefully selected features make the model more reliable. Even when given new or unseen student records, the model is still able to perform well. This is because it is not focused on by unnecessary or noisy data, and it focuses only on patterns that truly affect student performance. And lastly, for interpretability, when the model is built using clear and relevant features like attendance, midterm, and final scores, it becomes easier to understand how the prediction is made. Teachers and educational institutions can interpret the results and identify which factors are helping on affecting a student's performance. This supports better decisions making in real-life academic setting.
After testing several methods, our group have selected random forest as our final predictive model. So why did we choose random forest? Okay, first of all, among the three algorithms that we have tested, SVM, logistic regression, and random forest has achieved the highest accuracy, which is around 99%. And it also works well with real-world data, such as attendance and SM scores. Besides that, random forest is also good because it can show what features are the most important when making prediction. To ensure that stakeholders such as teachers, counselors, or school administrators can trust and adopt our models, we have focused on several trustworthy factors or elements. The first one is explainability. By using feature importance analysis, stakeholders can know which input like attendance or SM score that contribute most to the prediction. This will help stakeholders to understand the reason behind the output. The second one is consistency. Our model has been evaluated using 10-fold cost validation to ensure reliability in different student groups. The third one is transparency. Compared to black box, the universe is more transparent, making it easier for a beginner to trust the outcomes more. The third one is transparency. Compared to black box, the universe is more transparent, making it easier for non-technical users to trust the outcome. The next one is pilot testing. We recommend that our model be introduced first using pilot testing, which will be tested in a small group or a department. This will allow the teacher to see the model in action, provide feedback, and build confidence before a full implementation. The last one is visualization. Models and output can be presented in dashboard or graph, making it easier for our stakeholders to interpret and understand the prediction. To ensure smooth adaptation of our model into an actual educational setting, we suggest the stakeholders to follow these steps. The first one is to start with a pilot program that uses one class or one semester data. The second one is to provide a basic training or short briefing session to teachers or staff to teach them on how to interpret the model's prediction. The third one is to integrate the model's prediction into a visual dashboard or report format that presents the results simply and clearly. The last one, conduct regular reviews on model performance and make improvement as needed based on user experience. When implementing a predictive model in education, it's important to consider ethical risks and responsible use. We have identified several potential challenges and planned ways to address them. The first one is bias and fairness. We avoid using sensitive data such as gender and family income. This data were either excluded or analyzed separately to avoid discrimination. We aim to use only academic-related features such as attendance and exam score to ensure fairness in our model. The second one is privacy. We have excluded identifiers such as first name and last name. The data that we trained and test were anonymized in order to protect student privacy. The third one is transparent. We use interpretable model instead of black box to ensure stakeholders will understand how decisions are made. The fourth one is accountability. We clarify who will make the final decision. Our model only intended to assist teachers, not replace them. So, the final decision about student progress should always remain with qualified educators. The last one is the risk of misuse. We strongly emphasize that our model should not be used to label or punish the students. Instead, it should help identify which students who may need additional academic support or guidance. That's all for us. In conclusion, we believe that our selected model, which is random forest, provides a strong balance between predictive power, interpretability, and ethical responsibility. Through explainable results, pilot testing, transparent use of data, and responsible implementation, we can ensure that stakeholders not only trust the model, but also benefit from its insights to improve student outcomes. With continuous monitoring and responsible use, this data mining model has the potential to become a valuable tool in supporting decision-making within the educational domain. That's all from us. Thank you. Mana dah?